Well, g'day, Max here again, welcome back to the shop. So this episode we're going to cover our efforts to carry out the heat treating on our arbors. Now, last weekend I did start recording some of it. That turned out to be a bit of a mission because you got that much going on, and then a couple of times I forgot to press record on the camera. So I've done two parts as two pieces as just a trial to see what would happen. Now I put a couple of those clips in, and then now I'm a bit more organised with what's going on, and I've changed the way I'm doing a couple of things. We'll explain hows and whys of what happened there. So what we did, we proceeded to heat treat these two arbors here. So we'll go with this one first. So what happened with this one, the plan was to heat it to cherry red and do an oil quench in pre-warmed oil, so that all went according to plan. So we did that, and I looked at it. Oh, we had a masking agent on it too. Okay, to go and find it. ATP 641 is a masking agent. You paint this stuff on. Now, this stuff's probably more suited to use in a heat treating oven, where you apply the compound and you wrap the part up in the stainless steel foil. But I wanted to try it on these parts, when I was flame heating, just to see how they would go. And I might try a bit more again later on for another trial, but no, it wasn't successful. I'm not saying there's anything wrong with the product. It's probably a good product used in the way it's designed to be used. In a heat treating oven, that is. I will have another crack on a couple of other pieces once I get this a bit more down pat. Okay, so what's happened with the product on, it was peeling off with the heat and with the oxy on it, heating the part. So anyway, so we heated our part. We were going for a cherry red until it went non-magnetic, so I have no way to measure the temperature. So I did go slightly above cherry red on it, and then we quenched in our preheated oil. Now, the preheated oil was hard to get a temperature on that with a heat gun. I was getting various results. Was approximately 60 to 80 degrees C. Well, it was definitely well above 60, I know that. And it did proceed to get warmer and warmer. So anyway, so we've hardened, quenched, and then we put it in the tempering oven, the toaster oven. So it had to sit before the part cooled down while it was still a touch warm. To go into a low temperature temper. Now that's supposed to be held at 150 to 200 degrees for 1 hour per inch of thickness of the material. So I'll put these in for an hour. Now that was another thing. When I was playing around seeing if this oven would actually do anything, and this is just a test piece to see how, well, I did discolour this. So what I found, because a toaster oven is not thermatically controlled, the temperature will just keep going up and up and up. So these did start to get away on me. They went slightly above 200. They didn't get to 240 or 250. As long as I think it's avoid, well, yeah, I'm on the edge of 230 degrees to 370 degrees, as we do not want the temperature to go to. So it's called a temper embrittlement. So I'm not exactly sure at this stage what that means. I'll have to look it up, but it's an area you don't want to be in. You'd be below it, you'd be above it, but not in that area. So we were pretty close to, and we may have edged into that no-go zone. So then I proceeded to do the second one. So same method, same temper, and then I give them a bit of a check with the hardens files. And I wasn't really happy with the amount that they came up. They didn't really, to me, it didn't come up that much at all. So what I did then, I cleaned this one up and I reheated this one, and I went hotter. I went way hotter than 850 degrees, and I did a water quench on it with no temper. Now there doesn't appear, there's no visible cracking that I can see. So, and then rechecked the hardness and compared to our first one, and it's come up a lot harder. So I'm very happy with the hardness of this piece. So what we're going to do now when we quench, we're going to use a bigger, I'll swing it around, we'll take a look. So this is our quench tank that we were using, the 9 kilogram fire extinguisher container with the oil in it, and that worked very well for a quenching container. Now this is what we're going to now. So this is what we were using to heat this to red hot and dip in the oil to preheat the oil, and we'll do the same. Well, no, actually we can't do it with this. So this is what we're going to be tempering into or quenching into now. So this is a bucket of, well, 20 litre bucket of water, and it's got 1.5 inches, 30 or 40 millimetres or so thereabouts of oil sitting on top of the water. Now this was a method my dad taught me years ago, and what this will do, when you quench the part in it will surround the part with oil, and you won't get the sudden chill of the water, so it will just cushion that effect a bit. So that should give us a better cooling rate. So we'll see how that goes on the next test piece. So I think I previously mentioned in another episode I had these two little slugs that I was playing around with some time ago. Now I hardened both of these. One's an oil quench and one's a water quench. Now the water quench one did come up harder than the oil quench one. So that's when I first started machining these things. I just wanted to know if we could still harden it or get anything, improve the hardness. So going by our samples we could. So at the end of the day, not knowing, I haven't got a clue, absolute no idea what the steel is. So I've just taken a wild guess and said, well, let's just treat it like 4140 and harden it as per 4140. But what people don't tell you, if you do a bit of research on 4140, there's oil hardening 4140, there's water hardening 4140, there's 4140 can't remember now. Yeah, it's 4140 you heat quickly to harden, and it's 4140 you heat slowly to harden. So there's 4 different variables, completely different methods of 4140. So you've got to have successful results, you need to know exactly which supplier your 4140 came from, and then follow those manufacturers' recommendations, and I will tell you if it's a heat rapidly, heat slowly, oil quench or water quench. So if you go scrap a piece of 4140 out of the scrap pile or off some unknown supplier who doesn't know where they got it from, you could be asking for problems. No. Anyway, so what we'll do now before we hook into hardening or going to the next pieces, the other thing is I allowed a 10th hour grinding allowance on these pieces. Now what never crossed my mind is the shrinkage that will happen on these parts with a hole cored through them. So this has a 1/2 inch hole cored through them, and it's only leaving me on this one here. There's a very tight tolerance on the small end. It's only leaving me 1/3 hour grinding allowance to clean this up. So fingers crossed it will clean up. Okay, so I've just checked the temperature of our quenching fluid. It's only 16.5 degrees, so I think we will give it a preheat. The reason why I didn't want to do it was I didn't want to mix the top layer of oil with the water too much. So, but we'll do it. And this is our rig for heating. So what we have is a battery drill. We have some fire bricks just to surround the part. If we turn the battery drill on, that'll slowly rotate the part so we can get some sort of even heat into it. When it's ready, we just unhook it, turn off the drill. Backyard heat treatment at its finest. That'll be alright, that'll be enough to chew off the water anyway. Leave that sitting in there for a minute. Okay, here we go. Oh yeah, prick. Okay, that looks good. Really happy with that result. That's far better than the last two, so let's get it wiped off. Okay, this is the second face mill arbor. So we're going to quench in preheated oil this time. We'll just see if we get a difference. Still a bit magnetic up the top there. Starting off pretty good there, I think. We'll follow it up. and into the quench. At least with the oil we weren't getting the popping and banging that was going on with the other arbor in the water. So that was scary. That was, I could virtually see the cracks happening in the part before we pulled it out. We can't do figure eights properly in there, it's not big enough. That's how you're supposed to move the part around in the oil. Leave it in there till it stops smoking. We're down to 100 degrees there, it's time to pull it out. Well, it's come out very black looking compared to the other one. Not nearly as clean as the other one that we quenched in the oil water mix. Okay, so we'll put this in a tempering oven. Before we do, we'll just check it with a file. It appears to be hard. We'll get them in the tempering oven and we'll check them both. Okay, we've got the two face mill arbors in the toaster oven, and this time we're keeping a real close eye on the temperature to make sure we keep them between 150 and 200 degrees C for 1 hour. So every 5 minutes I keep checking the temp. Okay, we nearly had a bozo moment. I've had this 1/4 inch slot drill sitting next to my computer for the last 2 or 3 weeks, scratching my head and thinking, what did I buy that for? Could not for the life of me remember. And then it just dawned on me, I think yesterday, it's for the keyway we've got to put in here in the 1 inch arbor. So that was lucky we caught that one before we hardened it. So I'll get set up and we'll bang a keyway in. Oh shit, this thing's close. Beautiful. Well cooked, that one. Okay, we've got through most of our hardening. To summarise it all, I guess, we go back to our first two pieces. The water quenching, which was that one, came out a lot harder than the oil quench pieces. And then we redid that to, in case it was some one-off thing we did wrong, and we had the same result. The water quench one came out harder than the oil quench one. So that's why we did the remaining ones with the water quench with the layer of oil on top of the water. They've all come up really well. I'm really happy with how they've come up. Considering we no masking agents on them or anything like that, the parts have come up quite clean. Well, I think they're quite clean, quite good anyway. So we had some concerns on the, what part were we doing? When we quenched this first face mill arbor into the water mix, you could hear that it's crack, 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 crack. I thought, oh, here we go, we're going to pull it all out. It's going to be all cracks running through it and everything. But I polished it up a few bits and pieces on it, and I cannot see any visible signs of any cracking or anything like that. Whether something may rear its head when we start grinding, I don't know. Hopefully everything will be alright. I would have thought if something was to crack, it would be visible. You know, so really happy with all of them. Now, the hardness of them in the water quench, I can't mark them with a 40 Rockall file, but I can with a 45. So they vary, or only just with a 45. It does vary a little bit of a couple of points, so they're midway between 40 and 45 on average, so I'm quite happy with that. Now we did run out of gas, so there's one complete one we never got done, and as we run out, we were in the middle of doing this one, so this never got to temperature, and this was the one before, and this never got hard as it should have either. So I'm going to run these through again when I get some more gas, and once these are done, then we'll go through and do the grinding procedures on them all. Now I did do a test grind on this one here, so we've ground this surface, hard to see in the light, bring it up close, and that's come up really amazing. That's one of the, probably would have to be the best surface finish I've ever got out of a tool post grinder. So we did try another wheel, and yeah, it's amazing. It's just like it's come off a proper cylindrical grinder. Can't believe it. So anyway, the grinding will be another video. So yeah, I'll harden these ones off camera, and then we'll do a grinding video and get them all ground. So we've got the ODs to do, the IDs to do, and the thread cutting to finish off. So I'll have to make a guard up for my tool post grinder. I'm not real big on running it without a guard, as we're running a bigger diameter wheel. Now my grinder normally only runs a 3-inch wheel, 75mm wheel, and my trial grinder had a 100mm, a 4-inch wheel, so I'm just going to make a bigger guard for the grinder. So we'll get cracking with that, and all good. So take care, and we'll see you in the next video.